tell me what you want to say. Akash.
Yes, sir.
You want to say something?
Yes, sir. In that, sir, the previous means table that you made in that, in the demands means in the last column, that penalty for the last row, not the column, the row one penalty. It will be 80 minus 102 though.
18. There is no figure like 18.
No, 80 minus 102.
No. 102 minus 100.
Why, sir? You told to take the lowest, nah.
No, I told you to,
Not
first
the
of all,
highest.
I told you to consider the highest number, and the next highest means if there are what numbers are present in the first column, 80, 100 and 102. So 102 is the highest number.
Yes, sir.
So if I omit 102 from the picture, then among between 80 and 100, which one is the highest? 100, not 80.
100.
Yeah. So yes. if I compare all the figures together, then 102, 100 and 180. So 102 is the highest, and 100 is the next highest. And we have to consider the difference between.
But in the
yes.
Sir, but in the previous, that last VAM problem that we did, in that too you have subtracted that 19 minus 40. In the previous last VAM problem.
No, I did the same thing. And probably this was because in the matrix we are not left with any other choices. We were not left with any other choices, so we did this. Only 90 and 40, 90 or 40, whatever you were saying, these numbers were present. So that's why we did like this. I do not have the problem with me right now, but we.
Sir, can you allow me to share screen and I can show it?
Yeah, okay. How to do it? I'm technologically I am a little bit. Okay, how to do it? How to give you the remote control? Okay, remote control. Then Akash.
It's written that only the host can share.
Yeah, can you share now?
Okay, so wait. So wait, showing.
Yeah.
I don't know how to. How will I wrote it? Okay, fine. Got, sir. Wait. So this problem. See, sir, over here you have done 19.
Where is the problem? I can't see.
Minus 40. 19 was over here and 40 was. The problem was somewhere around.
Share the screen.
No, sir, I'm sharing my video, sir. I'm sharing my video.
But I'm.
Oh. Akash, nothing visible. Nothing is visible, Akash. Please share your screen.
Sir, he's showing in his video only.
Oh.
Video. I'm showing my video.
Go to his video, then only you can see. He's switched on his screen and he's showing the copy.
Akash, I cannot.
Video দিলে দেখা যাচ্ছে না।
Video দেখা যাচ্ছে না, কি করে বলবো?
Yes, sir.
জরম করে দেখা যায় না।
Sir, I'm dictating the problem. The problem was what Akash was saying, that in the last class, what you have shown in the VAMS method, there are 4 columns, 19, 30, 50 and 10. And when we calculated the penalty, we have calculated 9. That means 19 minus 10. That means lowest minus second lowest.
What were the values? Tell me once again.
19, 30, 50, 10,
50, 10.
70. Then again in the second row it was 70, 30, 40, 60. Third row it was 48.
Yes. Okay. Understood. Lowest and next lowest, not highest and next highest. Lowest and next lowest. Got your point?
Yes, sir. So in this,
Yeah,
we have calculated 19
yes.
minus 40.
Yes.
That's why I'm asking, like,
No.
it will be 102 minus 80
Yeah.
though.
180.
What?
180. 80 is the lowest, and next lowest is 100. Just a minute. Huh?
Yes, sir. 80 and 100, so it will become 20.
Yes, sir. It will become 20.
Actually, I do not. Just a minute. If anybody can show me the screen, if you have written, if you can show the screen properly in the page, then I can tell you. Actually, I am in this particular hodgepodge. I am missing the actual point.
Sir, no, sir. You can see the video feed of mine.
Okay, let me abort the control and let me share a particular screen with you. Just hold on, and let me show you. Let me clarify the doubt first of all. Just a minute. Just a minute.
Okay, sir. Sir, okay, sir. Shumona.
Yes.
Shumona.
Yes.
সুমনা তুই বুঝতে পারলি তো আমি কি বলছিলাম?
হ্যাঁ আমি বুঝতে পেরেছি, আমিও সেম ডাউটটা করছিলাম।
ওকে ঠিক আছে ঠিক আছে।
I'm going to share the very first note of the Vogel's approximation method, which I shared with you earlier when we studied VAM. Now you see, can you see my screen right now?
Not yet, sir.
No,
okay.
Sir.
It is being shared.
Yes, sir. Now it's okay.
Now it's okay, na? Now you see this calculation of penalty section. You see this section. Let me select a cursor pointer. This is calculation of penalty. What is written? For any row or column, select the minimum and next minimum element of that row or column and set their positive difference as the penalty of that row or column. Now I'm first of all talking about the video which you shared with us just a few minutes ago. In that particular video, we got to know that we had two values. We took the positive difference of 19 and 10. What were the other values present in the row? What were the other values present in the row? 19, 10, and
There are four values.
19, 30, 50, 10.
Yeah, 19, 30,
50, 10.
Yeah, 19, 30, 50, 10. Now, among these four values,
Then
which one is the minimum? 10?
10.
Okay, and if
and
you
the next is 19.
Yeah, and if you keep this value, keep this particular thing aside, 10 aside, the next minimum is 19. So I'm actually considering the positive difference of between 19 and 10, which is 9. Now, if you talk about the current problem,
Yes, sir.
If you talk about the current problem that is corresponding to the Denver column, the three values are there. That is 80, 100, and 102. So according to this rule, the minimum is 80. Which one is the next minimum? That is 100.
100.
100. So the positive difference, that is 100 minus 80, that is 20, will be considered. Not 102 minus 100. If I have said so, then
sir, but you have written it wrong then.
Yeah, I wrote things wrong. I know, because of this pen problem. I couldn't control the pen. Now I'm going to write it in a proper way. Okay, so I'm going to rectify this particular, because it happened because I actually got stuck with this pen.
You wrote, sir, in the penalty in the Denver column, you wrote 2 and 107.
Yeah,
that's why I was having confusion.
Okay, you are not. It should not confuse. Let me start afresh then. Let me start afresh.
Yes, sir.
Yeah. Okay. So this is Detroit and this New Orleans, and the values are, now the pen is all right. 80 and 100 and 102. Now it is smooth. 215. See, if there is a trouble, like technological trouble and any such of kind, when we take class in the classroom, when the student starts troubling, then also we got actually what? Disoriented. Here also, here students are disciplined, but my technology is not disciplined. So this problem happened. I got lost. So this is AI. AIs are given to be 1,000, and this is 1,500, and that is 1,200. And my BJ's availabilities are 2,300, and that is 1,400. Now, first of all, we need to check whether AI and summation AI and summation BJ, they are same or not. And we have already checked it. The value is 3,700. So we are writing it over here, 3,700. So the transportation problem is a balanced transportation problem. We are going to calculate the penalties now. So we are going to put another column and another row, introduce another row over here. So penalties are calculated just now, as I discussed. Penalties are calculated by taking the minimum element from the row at which the penalty is being calculated. If I'm calculating the penalty for the first row, we will first consider the minimum element and the next minimum element. So the minimum element here, only two elements are present, 80 and 215. So the minimum element will be 80 and the next minimum will definitely be 215. So the positive difference, their positive difference will be 135. And in the next one, next row also, the minimum element is 100 and the next minimum is 108. So their positive difference will be 8.
8
and that will be.
And then the next one is
34.
34.
34. And for the penalties for this column, the minimum element is 80 and the next.
Yes, so that one you have done mistake.
So that will be 20. That was the mistake part. And here also the minimum
40.
element is 68 and that is 108. So the
40
penalty is 40. I think it is all right now, Shumana, Akash.
No, yes, sir, yes, sir, yes, sir, yes, sir, yes, sir, yes, sir.
Okay, then this.
Yes,
if
sir,
I
right.
Yeah, okay, then if this is these are the penalties, and out of all these penalties the maximum penalty is 135. This indicates that in this row I am going to put my allocation somewhere, and where the answer is in the least cost cell. So in this particular row the least cost cell is 80, and I'm going to put an allocation with the help of the formula minimum of AI plus AI comma BJ. The corresponding to this particular cell value, the AI is 1,000 and BJ is 2,300, and therefore I'm going to put 1,000 over here, and this is exhausted, and the balance amount, that is 1,300 is written in this place. Okay, so we have got our first allocation. Now in the next matrix, I'm not going to consider this Los Angeles part anymore. And my new matrix becomes with Denver and Miami. And then we have Detroit, and we have New Orleans. And the costs are 100, 108, and 102, and 68. These are the costs, and the availabilities are 1,500 and 1,200, and the destinations are, the BJs are 1,300 and 1,400. So you see that the sum total of this is 1,700 and sum total of that is 1,700, and therefore the transportation problem is still balanced. So I'm going to calculate the penalties once again.
It is 2,700.
Yeah,
2,700.
Yeah, 2,700. Sorry, it is 2,700. So I'm going to 2,700. So this is the transportation problem is still balanced, and I'm going to calculate the penalties. So you see now if you want to calculate the penalties, you see that in corresponding to the row, the minimum element is 100 and the next minimum is 108. There are no other choices. So the positive difference 8 will be considered. Here the minimum element is 68 and the next minimum is 102. So the positive difference 34 will be considered. And now this column has only 2 elements. So their positive difference will be considered. So that is 2. And here the positive difference will be 40. And the highest penalty among all is 40. So we put an arrow mark like this. It indicates that somewhere in this cell, somewhere in this particular column, we are going to put our allocation. Where to put our allocation? In the minimum cost cell, and the minimum cost cell corresponding to this column is 68, and 68 can get max 1200 from New Orleans, and its actual demand is 1400. It is situated in Miami. So I'm going to give it 1200 items from New Orleans. I'm going to scratch it, and the balance amount, that is 200, is written over here. So we write 200. So since the New Orleans chapter is done, so we are going to omit this from the picture, and we proceed further. Next we go to the matrix where only Denver is there, Miami is there, and Detroit is there. Okay, and this is my simple matrix which I have got. And the costs are 100 and 108. These are the costs. Availability is 1500. And the BJ, the destinations have demand, which is equal to 1300 and 200. Now you see that if I add these two figures, 1300 plus 200, that is 1500, it is still balanced. It is still balanced. And if you want to calculate the penalties once again, for this, you will see that if you talk about the column, if you talk about the row, then this row has the minimum penalty 100 and the maximum minimum cost element is 100 and the maximum is 108, and the difference 8 is written over here. If we talk about the column, the minimum element is 100 only, so there is no other option. So we put 100, and here the minimum element is 108, no other option. So we are putting 108 over here. And this 108 is the maximum penalty. So we are going to put some number in this particular cell because this is the only cell. And we are going to put the minimum of 200 and 1500, and which is 200, you see. So we are going to cancel it, and we are going to write the difference over here, which is 1300. We don't have to write any further matrix because if you do so, only Denver and Detroit will remain, and with the cost cell, with a cell with cost 100 in it, and its demand is 1300 and its availability is 1300. So in this particular cell, we can very easily put 1300, and our job will be done. So this availability and this requirement has also been fulfilled. So we have got our solution matrix. So I think it is all right now. This method which I've applied over here is called the Vogel's approximation method. This is called the Vogel's approximation method. Now in the next page, I'm going to check its optimality. And you are going to, you just copy this particular matrix quickly in your, you write the matrix in your copy, and I'm also going to write it so that I can take the reference from to do the calculations, to carry forward with the calculations in the next page. Okay. So let me quickly write the solution matrix, and you also copy it. So how many allocations we have got? We have got allocations at Los Angeles and Denver, that is 1000. And then we have got allocations at New Orleans and Miami. The allocation is 1200. And we have got allocations at Detroit and Denver, that is 1300. And we have got allocations at Detroit and Miami, that is 200. So in total, we have got 4 allocations. So
yep,
we are going to write the solution matrix quickly over here. So we have Denver and Miami, and we have Los Angeles, and we have Detroit, and we have New Orleans. And the cost matrix is 80, 215, and the next row we have 100 and 108, and lastly we have 102 and 68. And the allocations are 1000 for this cell. For that cell it is 1300, and for this cell it is 200, and for that cell it is 1200. And therefore the transportation cost is rupees 80 into 1000 plus rupees 100 into 1300 plus 108 into 200 plus 68 into 1200. Anybody please please calculate this for me and tell me what is the value. Okay, please tell me what is the value of this. What is that?
313.
Okay.
200.
200. Okay, so this is the transportation cost. I'm going to check for optimality. I'm going to quickly check whether this transportation cost is optimal or not. Okay, so we are going to write the Cij matrix unallocated first of all. So for Denver and Miami and these factories, let me write these factories first of all. New Orleans. I'm going to put star over here. I'm going to block these number figures. I'm going to block these cells because these are allocated cells. I'm going to put the value only in this position, 215 and 102. So we have got our Cij unallocated. Oh, one more thing. Let me check whether this is non-degenerate transportation problem or degenerate transportation problem. So here number of row is 3 and number of column is 2. So actually allocations must be equal to 3 plus 2 minus 1, which is 4. And actually we have got 4 allocations. So this particular solution matrix is non-degenerate. This solution matrix is non-degenerate. Now we are going to calculate, we are going to write the equations for allocated cells one after another. So first equation is U1 plus V1, which is equal to 80. Second equation is U2 plus V1, which is 100. Third equation is U2 plus V2, that is 108. And the last equation is U3 plus V2, which is equal to 68. Just check. And if anything is wrong, you can immediately point to me. So these are the equations, and these equations are for, you already know it, these equations are for allocated cells. These equations are for
the last equation is
last equation
U3
is
plus
V2, because there are 2 columns only.
Okay.
And 3 rows. Okay, so how many variables are there? Number of variable is exactly equal to the number of sum total of rows and columns. So number of variable is how much? 1, 2, 3, 4, 5. And number of equation is 4. So one variable will be having independent choice. Only one variable will be having independent choice. So let us put U1 equal to 0. And for if U1 equal to 0, then your V1 is equal to 80. And when V1 equals to 80, then your U2 becomes 20.
Sir?
Bolo?
হ্যাঁ বলছি যে এটা কি প্রত্যেকটা ক্ষেত্রেই এরকম একটা সেল আসবে যেটাকে আমরা কনসিডার করব জিরো, একটা বা দুটো সেল?
তিনটেও আসতে পারে, চারটেও আসতে পারে।
যেমন
যদি if in a particular problem you have 10 variables and 6 equations, then 10 minus 6, that is 4 variables has to be taken independently, has to be chosen independently. It depends entirely.
Okay, sir.
This particular formula will be discussed in section 1 once again, because I have not discussed this particular formula as a theorem. It is a theorem actually, and I'll be discussing it in details when I shall discuss simplex method in section 1. So the rule will always remain same for any problem. So if you put u1 equal to 0, and yeah, you can ask me this question that, sir, why are you taking u1 always? Why are you taking u1 to be 0 always? Because you could have taken v2 equal to 0. The answer is yes, I could have taken v2 equal to 0, but some sort of connection, I'm just doing it without any loss of generality. I have become habituated by taking u1 equal to 0. I could have started with v2 equal to 0 also. Then there wouldn't have been any problem. So you can repeat all the calculation once again by choosing an independent variable of your choice to be 0. And you can check whether you are getting the same result as mine or not. Okay, it will be a good practice then. So if u1 equal to 0, then v1 equals to 80. And if v1 equals to 80, your u2 becomes 20. When your u2 becomes 20, then your v2 becomes how much? 108 minus 20, that is 88. And when your v2 becomes 88, your u3 becomes 68 minus 88 minus 20. Okay, so I have got all the numbers. Let us write our uij plus vij matrix. So ui plus vj unallocated matrix. Let us write it unallocated. I'm trying to do the calculation in the same page so that you can take the reference always. If I change the page, then it creates very problem. And I'm happy to see that MBA students, and I'm taking other classes also in other sections, I'm seeing that MBA students are very active, and they are actually, I can say that, yeah, on the other hand, the students are actually doing calculations. I'm not just talking to, it is not like that I'm talking to no one. People are listening and people are doing problems. They are rectifying me. They are clarifying doubts. They are active participants. Sometimes they play music.
Sir.
That I can bear. No problem with that. So for Miami, yeah, bolo.
Sir, del ij, there are no, in del ij matrix there is no negative value.
Yeah, okay. Yes,
so
yes.
the transportation cost should be minimal.
Yes, yes. So what is that value, Akash? Ui plus vj. What is the cell value you have got it here? In this cell?
Wait, sir, wait. So the ui
u1 plus
80.
u1 plus v1.
80.
Is it 80 or 88?
What,
80 or 88?
80.
80. Okay.
80.
Okay, and then this one? This one, Akash?
So sorry, it will be 88, sir. 88.
Yeah.
88,
That's what that was. What that is what 88. Yeah. And what is
and
that?
That one is 60.
60. Okay. 60. So you see, you can if you write the delta ij matrix. If you write the delta ij matrix now, and you know delta ij is the difference of Cij and ui plus vj. Then you see, I'm not writing the matrix here. You can very well see that this figure is greater than this, and that figure is greater than this one. Okay, and therefore obviously this matrix will be greater than or equal to 0. All the elements of the matrix will be greater than or equal to 0. Not equal
Yes,
to,
there is no negative value.
there is no negative value. So therefore this transportation cost, rupees 313200,
It's minimal.
is minimal. And actually I have solved a problem which is there in the, I have solved a Hamdi Taha books problem. It is there just in the starting page. I'm going to show you the screen. I'm going to share the screen with you. Just wait. I'm stopping this particular share. Probably you have written what I have written over. So I'm going to share the books.
Yes, sir.
Just a minute. See, actually I have solved this problem. Just a minute. Definition of transportation model is there. And see, Denver, Miami, Los Angeles, Detroit, New Orleans. The matrix is given, and they have not solved the problem. Actually, they have told you, they have told in the next page that they have shown the answer only, that rupees 313200, and they have written something. You can, if you can see that they have mentioned the optimal solution of this particular problem has been obtained by TORA. TORA is the software, statistical software. Sorry, not statistical software. It is actually meant for operations research, and the TORA can help you to find, to solve the all these tedious. It can get your, you can get rid of this particular manual calculation by using TORA. TORA can help you to solve the problems of operations research, transportation methods, Vogel's approximation method, check optimality checking, everything.
196 page.
What?
Page number 196.
Page number 196. You have the book with you, so you can go to this particular chapter, transportation problem and its variants. There in the third page, you are going to get this problem. So TORA is a software by which you can solve the transportation problems. But since the problem has not been done manually, so here in this particular class, I have shown you the solution of this particular problem, how to solve the problem manually using Vogel's approximation method. And here you see, for the new students, already I have discussed in one of our classes that they have actually discussed what do we mean by balancing of transportation model. Balancing of transportation model, the transportation problem becomes unbalanced when the availability, some of the availabilities and some of the requirements are not same. Okay. For the time being, since this particular, if you go by the syllabus, you see that actually all the topics of the transportation problem section has been discussed. But I shall not say that we have understood all the aspects of transportation problem, because there are some other cases are also there where you need to you need to look for the way out for those particular problems. Okay, some other interesting what should I say, situations are there which also needs to be discussed. So in the next class, I shall try to find out a problem where actually I can discuss that untouched section of that situation, which I am actually talking about right now. The situation is very interesting, and in my today's problem, the situation has not actually occurred, so I couldn't discuss it. If the situation doesn't occur, how can I discuss it? If I say something to you, you'll not understand. If I don't solve it, if I don't show you the calculation by myself, so that part also only remaining. I will try to look for a particular problem where that situation which I'm talking about appears, so that I can discuss it in the classroom. After that, I shall move on to the section 3, that is assignment problem. Assignment problem is a variant of transportation problem, and it is also not complicated. It is far more easier than transportation problem. And in this chapter, the page which I'm sharing with you, the assignment problem is there, because in Hamdi Taha's book, they have not set separate chapters for assignment problem, because assignment problem is a special type of a transportation problem. Okay, their mathematical models are actually same with a little bit of modifications. So we shall finish this particular section then, and after that we shall go to section. We'll go back to section 1 where we started, and we discussed only the graphical method for solving linear programming problem. We shall go back to that section and we'll start discussing simplex method, artificial variable technique, VAM method. All these methods are very tedious and very big. Okay, so we shall finish that section, and lastly we will do the theory of games. Okay, now after we finish all the discussion of all these methodologies, then if I get a proper software, I'm trying to find out, trying to deal with the software. So if I get chance, I'm going to show you, I'm going to discuss how to solve these problems using software. For some problems I may use Microsoft Excel. For some other problems I may use the software called Maple. And if I can get hold of Tora software, because I'm desperately looking for that, I'm not getting the proper link. So if I get hold of Tora software, then we shall try to learn to know how Tora software works to deal with such kind of problems. Okay, so this much for today. I'm going to end my today's session. The time is also running out, and if you do not have any problem, then I'm not rejoining in today's class. We shall meet in the next class. Meanwhile, you read this chapter and try to solve the problems by this northwest corner method, least cost method, and Vogel's approximation method. Here you see that northwest corner method and least cost method is there. RMM and CMM is not there, because RMM and CMM is not that important as these three methods. Okay, so this much for today. We shall meet very soon in the next class. I shall try to take another class in this week also. Let me talk to the coordinator. Okay, so bye for now. We'll meet soon.